All right, looks like we can get started here. So thanks again for joining us today. My name is Kamala Thorpe, and I'm here with Dr. Alexi Geek, who will be doing the more technical part of the webinar today on engineering smarter optimization for geometric design. So before we get started, just a little bit about Softtree. We've been in business for 25 years, or over 25 years, and we've been developing civil design software for that long. And the core of our company, we have a very user-centric philosophy. We really try to keep our software easy to use and stay away from the steep learning curves that can exist in the design software industry. And we are constantly innovating, trying to tackle new problems. And the optimization technology that you'll see today is one of the major problems we've been tackling recently. So just a quick outline of what we're going to be covering today in the webinar. The general idea of the webinar today is learning how Softree Optimal can help you engineer smarter by allowing you to focus on the real engineering problems at hand and less on manually adjusting a design within CAD software. Also, compare and back up every design decision. So I'm going to start with an introduction to Softree Optimal, just talk a little bit about the technology, and I'll hand things off to Alexi, and he will show you how you can set up your design parameters in Softree Optimal to create a design based on the real engineering problem at hand, as opposed to manually adjusting an alignment in CAD software. And then he will show you how that's done using optimization. And at the end, we'll show you how you can compare multiple design options by working with costing data that Softree Optimal provides. So Softree Optimal optimizes the vertical alignment of a road or corridor by mathematically minimizing earthwork costs. So it solves the complex 3D problem of minimizing excavation, embankment, and haulage, giving your user-defined constraints. So this optimal solution is determined based on the original ground surface, the existing horizontal alignment, and the cross-sectional data taken from whatever road design package you are using, as well as the design parameters and constraints and unit costs that are entered by the user into Softree Optimal. So this is just a brief workflow outline of how Softree Optimal can complement your existing design process. The ability to quickly generate an optimal vertical alignment for a design, whether it is in Civil 3D, Bentley Civil Design Products, or Softtree's easy-to-use road design software package, RoadEdge. Using Softree Optimal has benefits both at the beginning and at the end of the design process. So Softree Optimal can be used for feasibility checking at the preliminary design stage. It can also be used as a means for quantitatively comparing multiple design variables at this stage as well to determine the lowest cost options before getting into detailed design. An example of this would be comparing multiple horizontal alignment options based on cost. And then your detailed design can be done in whatever program you are using. And then Softree Optimal is also useful at the finalized design stage to check a design, to perform final optimization and determine the lowest cost alignment for a finished design, and also for estimating construction quantities. So in the webinar today, the main focuses are going to be on these three aspects of using Softree Optimal. The construction quantities, we'll talk a bit about costing, and then we plan to talk more in detail about the way that Softree Optimal can give a detailed material movement schedule and all of that in a future webinar, but today we'll just be talking about costing. Before I pass things on to Alexi, I wanted to show you a list of our upcoming webinars. So please sign up for any or all of them. We'd love to see you again. And with that, I'll pass things on to Alexi, and he will show you Softree Optimal in action.
Okay, good morning everybody, or good afternoon depending on your time zone. I just want to confirm with Camila. Thank you, Camila, for the presentation. Can you see my screen?
Yes.
Okay, well, that's good. No, no problem. Okay, so for this webinar, I'm going to use the design provided by one of our clients in the US. So you will see that all the units will be Imperial. Um, so for this project, our client used heavily at the early stages Softree Optimal. And as I will show you during this webinar, it allows him to make some interesting design decisions. So just a little bit of a context about this project. It's a county road. It's a two-lane county road. The length of the road is 2 miles. And essentially, the overall goal of the project was to try to increase the design speed from 50 miles per hour to 50 miles per hour, 55, sorry, miles per hour, over the entire length of the segment of the road. So this is something that is actually quite overlooked in general when we use Softtree Optimal, and I will quickly mention that, is this concept of feasibility. So, let's say the original road here is actually, you can see it's in the dark, in black. Let's say you wanted to have a design, a speed design of 55 miles per hour. Well, it's actually not obvious in general that it's actually even possible to do that. So Softtree Optimal can be used as a feasibility tool. In other words, it can answer the question, is that even possible to have a 55 mile per hour design over the length of the road? Well, I mean, in that case, the answer is pretty trivial. It's, of course, it's going to be yes, but it might not be the case. We might imagine a situation where we have a right-of-way constraint, we have control points imposed by intersection, driveways, and so on. So this idea of feasibility can be actually critical. I mean, in this example, it's not the case. So let's say I want to generate an alignment with this new design speed. So I'm going here in the options panel, and I'm going actually to set up the standard properly. So the sag and crest corresponding to this 55 miles per hour design speed is 115 and 114. So when I've set it up over the entire length of the road, then I can actually just press optimize, and I will get quite quickly the result. So of course, if we get a result back to my feasibility comment, it shows that there is actually a design, 55 miles per hour design that's possible. So we have to wait a little moment here. So you can see that the optimization process is in fact quite fast. It's not always the case. This road is relatively short, so this is a good scenario for Softtree Optimal in general. But there we go. So I'm not going to actually make a full comparison in terms of a mass flow diagram. I will do that a bit later. Here I'm just going to talk about the cost. So here the cost of the road is essentially, as far as we have done it now, the cost of the road is consists of the cut cost that you can see here in this panel here on the right hand side, the fill cost, and then the whole cost. So the sum of these three numbers account for the whole cost, the total cost. So I want to mention that here these are actually real values. We actually work with our client to get accurate numbers. So this is the actual cost of the road. So that's in the gray zone here. This is actually the original cost of the design that was actually provided to us, and that is the cost of this optimized road. So you can see that actually the difference is indicated here. So we have overall a 10% difference in terms of cost. So if I go into the profile window here, you can actually see that the alignment are very, very. I mean, of course, the scale issue, right? But they actually look very, very similar. If I zoom in, you will see that at certain locations they are actually different. So, for example, here I can actually measure, just for the sake of it, let's just do it. We can see that the difference here is about 8 feet. So it's quite significant still. So those small local changes will essentially account for the difference that you are actually observing here in terms of cut and fill cost, right? So, so that's our initial attempt. So the title of this seminar is about making smart decisions. So let's see how we can use Softtree Optimal in this context. So if I go back here into the profile, so remember that originally this road was actually 50-mile-per-hour road that so it actually continues over there, and that we try to increase the speed, design speed to 55, right? So you can see there's actually quite a sharp curve here. So the natural question is that, well, we originally decided to extend this design speed all the way to 55 the station number 51,000-ish. Well, maybe in fact, we could actually, instead of extending the design speed all the way here, maybe we can just actually only make this design speed up to the station around 50,000, just to take into account this sharp curve here. So let's try to do that. So let's try another optimization here. So if I go into this new optimization here, the only difference with the previous one is that essentially from the station 50,450, I've actually lowered the second crest. So I actually reduced the design speed from 55 miles per hour to 50 miles per hour. So let's see now what's the impact of this minor change in terms of the cost. So as I said, earlier again, the first thing that Softtree Optimal do is check if that even change is even, possible. So, it's what I've called the feasibility. So let's just do again the optimization for that new set of standards. So again, here, what I'm just trying to do is see what about here at the end of the road, where the sharp curve is. I'm going to try just to reduce the design speed and see what's the effect. So of course, we expect actually in decrease in terms of the cost. That's the whole idea behind doing this change, and we want to see how much savings can we make. Okay, so this is the new alignment. All right, so I'm just going to actually change the. I'm going to okay. So this is actually the alignment is in green. I'm going to actually display the original one so you can actually observe the difference. Let me do this. Okay, there you go. Okay, so blue was the original one, and you can see that the green is the new alignment with the smaller design speed, and you can see that actually the curve is actually sharper. Let's see what's happening in terms of the cost. So the original test we've made, the cost was like 468,000, and then the reduction was, remember, 10%. And here we get down to 390, and then the reduction now is 25%, right? So, again, that is actually expected as we lower design speed, but we are not exactly sure how much of an impact this change could make, right? So now we have actually been able to quantify that. So now, essentially, this is the time to make a decision whether to stay with the original solution of having the design speed to 55 all across the original range, or just make this change as we do now. So it happens that the designer for this project decided, based on this information, to actually reduce his range for the 55 miles per hour design speed to this exact number, so to the station, essentially 50,450, right? So he actually made a decision based on this cost reduction that he observed obtained from Softtree Optimal. So once that's done, this is actually maybe a little more technical, but essentially the two previous alignments were obtained quite fast. So we have a method to obtain quickly these alignments. Essentially, if I go back into the standard panel, this is what I call curve fast. They are not really practical from engineering point of view, those alignments, because they essentially consist of a curve, consecutive curve. So to actually build a proper alignment, we need to be able to insert tangents. So this is actually my last optimization right there. So this optimization, the only difference between the previous one, fast 2, and this one, essentially is the fact that I have actually now I'm trying to insert tangents. So it will make actually practical alignment from an engineering point of view. Otherwise, the curvature parameter is actually the same as the previous one. So this will take a little longer to solve, and that's why, to make those decisions that I just showed you at the beginning, it's actually best to use fast curve, because we can obtain solution quite quickly. And here, this is just exactly more for final design, essentially, right? So it takes a little more time. I'm going to start the process, and then maybe if there's any question in the meantime, I will answer them. So Camila, I think.
No, there aren't any questions yet. But if anyone has questions, please type them into the question panel. We'd be happy to answer.
Yeah. So this is actually the same process. I'm optimizing. So now I'm happy about my decision of having a slower design speed in the end, and I'm just gonna actually get a proper engineering alignment now. Right? So I will not. You will see that the process is a bit longer, but I have done the optimization essentially prior to this webinar, so I will show you the result. So you see that it takes a little more time, like in the previous optimization. The result was almost instantaneous. Here it's really cranking some numbers here. So, okay, so I'm just going to cancel it. It's not really point waiting. I can tell you that you obtain the solution, let's say between 5 and 10 minutes, so it's still pretty quick. All right, so I'm just going to cancel it now, and I will pop up another actually location module here, this one. So this is my actually final design, curve 1 again. So let's have a look at the cost. So what is first important is that I said is this the cost here is 400,000. It's actually quite close to the fast, so which is 390. So again, like this is just like a quick way of obtaining an alignment, and this is more an engineering alignment. In general, the difference will be quite small. So the decision we make based on the fast curve, we can be confident about them. So yeah, so let's just compare finally the cost saving of doing this optimization. So the original design the preliminary design done by the engineer was like $520,000, and then now we got that down to 400. So overall the cost saving was like 23%, right? So again, you can see that the alignment are quite close. They are locally at certain place they are significantly different. Like for example here, again I'm gonna measure it. You can see that the difference is like 4 feet. So you have these local difference that are enough to essentially account for this difference in this saving in terms of cost. So I promise you that I will show you some mass cell diagram, so we can actually superimpose the original mass cell diagram from the original design and the final optimized one, and you will see that definitely that there is a significant difference. Let me show you that. Oh, okay, I actually lost the page. So, oh, there you go. Okay, so that's the one. Okay, so these are, I just put them together in an actually different, on a PDF. So these are actually the two profiles. So this is the profile and then the master diagram from the original engineering profile, and that's the one we get after optimization. So you can definitely see that the optimized one is way more compact, and so which indicates essentially that there's actually a smaller mass movement. And of course, this is being reflected in terms of cost saving, right? So again, here the only thing I've done essentially is I've tried to change the k-value or the design speed locally, and then see what was the impact in terms of cost. That's one thing that you can do with Softtree Optimal. There's many other things that you can actually do. For example, you could also do the same thing with grade, decide to change the grade. So what would be the impact of changing the maximum or minimum grade, right? You could also decide to, if you decide to tie your alignment in terms of elevation or grade at a specified station, then you can actually also see what's the impact of that the decision, right? You could also, for example, see what's the impact of having certain level of constraint. So what's the impact, for example, of having a right-of-way, or what's the impact of having, minimum cut or minimal, again, over a certain range of station. So, and quickly, once you actually set up an extra constraint, and quickly as I show you, you can actually optimize, get an alignment if it's feasible, if it's even possible, and get a cost. And then you can actually compare your cost with the cost you had before doing this change and see what's the impact in the you can quantify this change, right? So, in that sense, Softtree Optimal can help you to make actually a lot of interesting and decision in terms of design. So I think I'm going to stop here. It's almost over. So Camila will be happy to answer any question. I don't think I saw anything there, but can you just confirm that?
Yeah, no, there's no questions unless any last call for questions. Otherwise, looks like we're almost done. Nope.
Well, I think that, well, thank you very much for attending. I think I'm going to leave the last word to Camila, but from my point of view, I'll thank you very much for your attention, and then I'll wish you a Merry Christmas and then a good time and good vacation time.
All right, thanks, Alexia. I don't have anything else to say, but other than that, we're going to send you a link to the recording, so feel free to watch the webinar again or pass it on to any of your colleagues. And I wish everybody a Merry Christmas and Happy Holidays.